Hi, everybody. It's my great pleasure to introduce my esteemed colleague, Dr. Julia Stewart Lowndes, who, in her 4 years here at NC, she's been working on the Ocean Health Index to help improve the reproducibility and the transparency of the Ocean Health Index. And she's going to be talking a bit about a recent paper that was just published about these efforts and about her successes. So, give her a warm welcome. Also, this is being recorded, so at the end, when you ask questions, please use the microphone. Don't do the whole thing where you put the microphone out here and then talk. Put it here. Thank you.
Cool. Hi, everybody. Thanks so much. One second. Thanks so much for having me. Yeah, I'm really excited to be talking about this, and especially today because our paper came out yesterday. And so not only do I love talking about this, but the timing is really great. So I'm going to be talking about the Ocean Health Index and kind of the narrative of our experience over the last 4 years. And before I get going, I just want to thank my whole team, both here at NCEAS, who's amazing, and our partners at Conservation International. So it's a really neat partnership that we have here with like the science and the management expertise is in-house on the same project. So just to get started, I'm just going to be telling more of a story than anything else here. So to start off with stories, I'm going to use Kurt Vonnegut's Shapes of Stories. And this is something that Nancy Barron, who's our in-house Compass awesome expert, told me about. And this is Kurt Vonnegut when he was a master's student at the University of Chicago, long before he became famous for his writing. He got really interested in the story arc or like graphical representations of stories. And so he created this axis where you have ill fortune to good fortune on one axis and the beginning and the end on the other. And there's some really interesting articles recently about this stuff, and you can also see a YouTube clip of him talking about this himself. So I encourage you to look at it. It's pretty interesting. But he has a couple different story arcs, and one of them is the boy meets girl story arc, where just a normal person, average day, comes into some good fortune and loses it, and then becomes better off through time. So you can think of a bunch of different examples of this. The first thing that comes to my mind is Star Wars with the original episodes of A New Hope, The Empire Strikes Back, and then Return of the Jedi. So you can think of this in a lot of different ways, but it's kind of a fun way to think about story arcs. So this is the same story arc as the Ocean Health Index. We started off with a big success, and then we had a pretty rapid jut down, but now we're better off than we were. So to fill in these inflection points a little bit, in 2012 was when we first published the Ocean Health Index framework, and we assessed all coastal countries globally using this framework. This is a big success after a long time of development and collaboration. And it was published in Nature, and it was a really huge triumph. It was the first time anything like that had been done. 2013 is when we went to redo it. And I'll gloss over that at the moment, but that will be a big part of my talk today. But where we are today is that we have a transparent and repeatable workflow. We've now repeated 5 of these global assessments for every single country in the world. And we've got over 20 different groups using not only our science, but our code and for their own regions and building off of each other's work as well. So this is the story arc of the Ocean Health Index. It's also going to be my talk outline. And I'll really be focusing on this 2013 to today period. And this is the story that we just published yesterday in Nature, Ecology, and Evolution. And 5 years of global assessments is also in press in PLOS One at the moment, which is exciting. So I'm just going to give a really quick background about the Ocean Health Index, hopefully in a way that you may not have thought of it before, and I'll try to keep the details minor because that can be a whole series of talks in itself. But the Ocean Health Index framework is based around the idea that a healthy ocean sustainably delivers a range of benefits to people now and in the future. So in a nutshell, there's sort of 10 categories that you might be interested in having to be able to comprehensively assess what a healthy ocean is. And so you'll score these benefits, or we call them goals, all on the same scale so that you can compare across them, and you end up with scores which we represent in this little flower plot on the right, where each petal of the flower represents a different benefit that the oceans provide, and how long those petals are represent how close you are to reaching your management targets. So just to dive a little bit deeper, each time you want to assess one of these goals, you actually need a bunch of models in order to get those scores. So the models will be based on the current status of that goal versus what it likely could be in the future. And there's a whole bunch of modeling that goes into that in terms of the pressures that are acting on these benefits versus resilience measures that might be in place to help them perform. Diving a bit deeper, in order to make models to represent those goals, you need to have a ton of data and a ton of planning of what data you're going to use, what's available, how you can work with what you have or plan for what you need and identify what you're missing. So there's a lot of planning that goes into it. And ultimately, the idea is that these scores would be used to inform management that is really transparent and scientifically driven. And the idea, too, is that these will be repeated through time. So once you identify the goals you'll be using and the models you have, you'll use those same goals and models through time, but reassess every year as you get new data. So this is how we developed this first framework in 2012, and then use new data that were available for 2013, 2014, 2015. So the idea, too, that is you would not only be informing policy, but you'd be informing better science each time around in terms of the data available. So this is the OHI in a quick nutshell, but I also think that I just wanted to pause here and say that this is the process that people do in science, right? Like I think about this with my thesis, where I had a workflow set up and then I'd get a new allotment of data, and then I'd have to repeat the same process too. So like having some kind of system in place is not just for big teams, it can be for yourself as well. So for the Ocean Health Index, we sort of think about this in terms of two parts, where there's these core features that make an assessment using this framework. These core features make this an OHI assessment, in that there's goals that will be modeled into scores on the same sort of scale. And then there's also this tailorable part of which goals you're assessing depending on where you're assessing from what. So, and by that I mean like whether you're doing an assessment in Israel or in Ecuador or in New Caledonia or on the northeast coast of the US. And so what goals are important to assess in these different places depend on where you are, and what data you have to drive those models are different for where you are. So there's there are these core features of an OHI assessment, and this sort of tailorability that makes it be able to be used in different contexts. Okay, so getting back to the story. Like I said, this was a big high point in 2012 when this really huge collaborative data-intensive effort came out. There were probably about 100 different data sets, tens of models, and 30 co-authors involved. So it was a big effort. And in 2012, this is the way we prepared all of those, or most of those data from those 100 different data sets. We wrangled them in Excel a lot of the time, where changing column names, shifting things around, extracting countries that were inland, averaging depending on the time scale that data were reported. There's a lot of data wrangling that went into it, and a lot of that happened in Excel. And we all sort of had our own systems of version control, where we would initial or date the actual file name in order to track change through time or contribution. And then we collaborated by sending these files back and forth through email. So there's a whole slew of email chains that were forwarded to different team members with different versions of different data. So it might not be surprising that this is why we had a low point in 2013, is because we had to not only track down where data were in different emails, then we had to look through the different data files and understand what had happened to each one, and then by hand again extract all of the land-based countries and all of these things that should have been a wheel we didn't need to reinvent. So the good news is we don't do that anymore, and we've increased our both our efficiency, since we're not reinventing those wheels anymore, and the time we've greatly reduced the time it takes to redo these assessments each year. And so how we've done that is by embracing coding and version control, which are something that I know this audience knows and practices. But also we've really embraced these new software tools that really make this collaborative and easy to share. So for coding, not only does this provide a completely reproducible or reusable record of what we did, so you're not looking at Excel spreadsheets and Word documents to describe what was done, but it's a record right there in the code that can be reused. And version control takes care of all of the bookkeeping that we'd been doing ourselves in terms of having every team member save these files that they downloaded into their own folders and having them name different things. So all of that bookkeeping is taken care of. And then we've also, as a team, we've become much more aware of best practices for collaboration, first with ourselves, so that I know what past me did, but also so that new team members who might be joining could get on board quickly, because that was another big part of the forwarded email chains, is that new team members needed to be on the receiving end of a bunch of forwarded emails as well. But I think too, a lot of our story is about the communication part of these tools, and how it's so much easier to share all of our work openly for free online, and in a collaborative way. So the same sort of coding and version control tools we use also drive the websites we build, documents we put online, and even online ebooks and interactive graphics and all these cool things that really bring our work to life. So there's a lot of words that you can call all this stuff: open science, data science, open source, a lot of things. We've been calling it open data science to try to, introduce another term. But anyway, it lowers the entry of barrier, or that's not what it does. It lowers the barrier of entry, not only for new coders just within our team, but also for our collaborators throughout the world. We've got scientists in the South Pacific and in Europe and all over the world who are also able to use these tools for free, which is also really neat to lower the barrier of entry. Okay, so I said there was this core part of the OHI framework and also this tailorable part, and that translates directly into the tools that we're using. So we have an R package that does all of the operations that are this sort of the core features of what makes an OHI assessment an OHI assessment. And then there's the tailorable part, where we leverage the sort of the structure that GitHub provides, where there's essentially a single place called a repository, where you can store a bunch of files and scripts and data. And so the combination of a folder on GitHub that is material to get started, and an R package lets them do their own assessments. So I sort of mentioned this before, but this is a little graphic of, so the coding and version control really help the reproducibility of our work. And that's what each of us do individually on our local computers. And then the collaboration and communication part of this really come through the harnessing the power of GitHub and RStudio for collaborating directly between our own computers and having shared file paths and systems that nobody has to come up with on their own, but we come up with together and then all use. And then communicating by sharing code and method and data through websites and other documents. So this is a figure from our paper. where the main takeaway is that each circle represents one of our global assessments, and the size of it shows how much time it took roughly to do. And so you can see that each repeated assessment now takes less time. And in addition, our focus has been able to shift each year. So the first year in 2012, we were really focused on the scientific methods. And then in 2013, we put a lot of focus on our data science methods. And that's now more recently enabled us to get back to more scientific methods now that we have this system that's really easily updatable. And in 2014, that's when we really sort of formalized the idea of this OHI Toolbox. And so now when other countries want to use the OHI framework for their own assessments, they'll start somewhere along the lines of the amount of time it takes in 2014. So they're not reinventing a lot of wheels themselves. They can sort of hit the ground running, and then hopefully it will take them less time each year as well. So there are about 20 countries working on their own OHI assessments at the moment. They're all in different phases. Some have completed scores, some are just in the planning stages. There's a lot of really cool stories coming out of each and every one of these regions that I'm not going to talk about today, but this is in particular facilitated by a lot of the work done by our partners at Conservation International. My collaborator Eric and I just gave another webinar about this where he gave a lot of great examples from this. So there's a link from our website about that if you're interested. Okay, so I want to show you some of the things that we're doing just so that you have something to look at instead of just taking my word for it. But we, with our OHI project now, we are doing global assessments every year that can be that result in scores that can be used in global policy. Like, for example, the United Nations is considering OHI as one of the indicators for its Sustainable Development Goal 14, which is the life below water. And there's meetings even in 2 weeks about this. Also, what we call OHI Plus are these independent assessments that other people use our framework with their data and their management priorities and their characteristics of their geographies in order to assess the ocean health of their own regions. So we call that OHI Plus. We've got our Toolbox software, and we've got 2 websites where we communicate all of our work. ohi-science.org is more of our technical science website, and that's what we maintain here at NCEAS. And oceanhealthindex.org is to a broader audience and mostly focuses on global scores. But we do most of this with our Git, our studio, and GitHub. And so really, if you think about the back end of all this stuff, we're doing a lot of different things in order to work as a team and do our science most effectively as possible. And part of that, is science and software development, but we're also really interested in trainings. And we've been training groups around the world to do ocean health index assessments. And so that started off with really the conceptual side of what the OHI framework was, but more and more it's teaching them the toolbox and teaching them good data science practices. And so that's actually been super rewarding as we've been moving forward as well. And yeah, I think that's what I'll say there. So I wanted to show a couple just examples. I think a lot of you might know what GitHub is, but this is a screenshot this is going to be a series of screenshots from our work. And what this is this is a public URL, so you could go to this and see all of the different sort of sub-projects that we have going that all contribute to this OHI science project. So you can see we've got a bunch of collaborators. I think the total count is 41 right now. And you can see that we've got, so I just highlighted, these are the most recent ones that we were working on yesterday. We've got the science behind the global assessment just right alongside a website for our new manuscript, right alongside a training book we're writing, an independent assessment that's going on in Hawaii, and our entire science website, and that's all together. And I think that's really cool that like the science and the communication is so interwoven. Yeah, I really like that about the way we're working. So this one repository down at the bottom called ohi-science.github.io is actually all of the code behind the website we made. And so that's pretty cool that we have this central hub for all of our work that is also created in the same way that we do our analyses, which means that we update it more frequently and it's more likely that we'll actually do it. So I encourage you all to come here if you want, and then hopefully it'll be more obvious how to navigate through it if you need to. For the global, for the science behind it, this is something that you might find in this repository where we have all of our code here down at the bottom of what the analysis is going to be, but we also are able to have really a lot of metadata and documentation written in a way that is pleasing to the human eye that can go right alongside the code, which means that it's just really powerful to be having something like this living notebook where you can have a narrative and the code right side by side. So this is something that you might find in the global assessment. But at the same time, we also can create a website from that exact repository. So we've created a pretty minimalist website, but where we point people to all the data they might need, exploring scores, learning more, like a link to a webinar we gave about this, papers, a bunch of different options. And so this is something we're starting to do more and more, is to create websites for the science that we're doing and the publications we have, so that there's another entry point to learning about what we're doing. Another example is that we create sort of a straw man website for these OHI plus independent countries, so that as they get started and they're trying to gain visibility to their project and get stakeholders to contribute and just feel comfortable about what they're doing, they're able to have a public front to their work. And then as they start developing more models and having more results, they're also able to have a place to put all of that. And again, this is all using the same workflow that they're using for their own analyses as well. Something else we've been doing is using our studio's new bookdown capabilities to actually create ebooks that you can read on your iPad or on your phone. And so this is up online, where it's still in progress. I think we've written chapters 6 and 7 at this point and have outlines for the rest of it, but already it's a way that countries can not only learn the toolbox, but now more and more we're going to put a lot of our materials on how to learn data science skills here as well. So there'll be a single place that you can read as well to learn all of this stuff. And then this is something we did for our paper that just came out yesterday. We made this website not only so that there'd be a quick way for anyone to see the resources that we mentioned in the paper and see how to contact us to join this kind of community, but also we've been listing the media coverage that we get from this paper as well. So we're trying to get other people interested in these kind of tools, and so it seemed like a good example of that. Something else that we do is we create interactive websites so you can actually explore the data and the scores that come out of these assessments. So this is using Shiny, and this one is for the Ocean Health Index global assessments. And so you're able to, I don't have a live link to this, but you're able to look at what scores are for each individual goal or for any other country that you might be interested in. And you have a bunch of options that you can extract data and dive down to exactly what you want. And then we're also using this interactive website just for fun for other papers that we published. So this is Casey's paper that came out last week. And he had some really beautiful figures in his publication that were snapshots of a lot of the awesome exploratory work that he did and a lot of the other figures that he got interested in. And so this is a way you can dive into the data, look by species or by region, look at coral specifically if you're interested. So it's just another tool and another way to communicate about our science. So I'm going to wrap up here, but in summary, these open data science tools have really driven not only made our own science better and more efficient and more reproducible, but they've let us do so many more things than we had signed up to do in the beginning, because it's really awesome to see what you can do, but also it's really neat to bring this stuff to life. And I think one of the reasons why we wrote this paper is we took a step back and said, this isn't just for the Ocean Health Index, it's for environmental science, and we really want people to be able to collaborate for environmental science of all sorts. So I know there's a lot more we could talk about, and I could talk about all this stuff for forever, but that's just a little overview, and thanks for listening.
Questions?
So that first year, I'm thinking about, any project that you take on, you're all over the place. You're trying out different ideas. How much do you think you would have benefited had you had the methodology in place in the first year as opposed to the second year? And is that really even possible, or do you need to know the shape of the project?
I think that we're constantly improving the way we're organizing things and shifting things as we go, but having everybody on GitHub from the beginning, I think, would be incredible, even if it means you're going to shift some folders around and split repositories later on. I also think, GitHub and R are not the only tools. Like using Google Spreadsheets more to collaborate would have been really helpful at the beginning as well, even though that's still not versioned and everything, but it would at least remove the emailing. So I think that having more tools to use from the beginning will help the project develop in itself.
Thank you for a great talk. I am interested in your thoughts on how resistant a lot of scientists are to share their code and also to package it in a way that is accessible to policymakers, stakeholders, decision makers who aren't scientists. And I think some of that is just because no one loves the idea of someone digging through the work you did to potentially see places where you cut corners or might have made a mistake. But I think a lot of it is also just that scientists aren't comfortable with people using models they build without fully understanding how they work. Mm-hmm. So I was wondering if you could talk about how you overcome that discomfort and what you would say to scientists who do other really important computational environmental science, but aren't doing as good of a job at getting it out there.
Mm-hmm. Yeah, I mean, this is a huge topic. I think for us, we didn't set out to work completely openly. We didn't actually have those kind of lofty goals, even though that would have been nice, but it was just more efficient for us to work with these systems, and it's free if it's public. And we were like, oh, that's a huge benefit to our mission, and it's so easy to do. So I think that's really how we got going. But I think that there's, it's a whole continuum or spectrum of how comfortable you are with sharing your work. And so if posting published papers online is as comfortable you are right now, maybe that's a good start. But oftentimes too, you can share your code online through GitHub without sharing your raw data, but maybe more eyes on your code could actually improve it. And maybe you'll see that somebody in a totally different field is struggling with that kind of model parameters just the way you are. And I think, we've seen basically just benefits at this stage. We've learned so much through Twitter and through other people seeing our code on GitHub and contributing to it, and also for the transparency of our work and sort of trusting the scores we produce. Being able to see the data that went into it and having a narrative of it is actually a huge benefit. So yeah, there's a lot more to be said, but I'll leave it at that. Yeah. Cool. Okay. Oh yeah.
What's the average learning curve have you found with managers of adopting or trying to integrate OHI into whether they want to kind of curtail it to have the OHI plus versus taking it straight out of the box? Is it pretty rapid or it's pretty variable?
So it's a big question. So OHI plus assessments, if they're going to do quite a few modifications and not just use it out of the box, it could take 2 years potentially to do a full new assessment. That said, in Ecuador, they did it in 9 months because they had a full data team and coders, and the government was on board. But I think in terms of the learning curve, there's definitely a learning curve with all of these tools, and there's so many, and where do you start? But I think having the architecture that we provide and then entry points to doing what you need to do that day, and then going from there. Like, we've started providing these new websites for people when they get started on OHI Plus regions so that they can upload pictures onto their website and write text using the R Studio GitHub workflow without ever knowing anything about R. So they can already see the benefits and get that win before needing to do anything else. So I think that's an important thing to consider. And I think too, these things, whether it's an OHI assessment or a lab or whatever, like, not everybody needs to be doing it all because you can't. So if there's sort of complementary skill sets and overlapping skill sets, not everybody needs to be developing shiny apps if that's not part of immediate need, or I don't know, kind of a weird answer, but there's different entry points, and we definitely introduced a lot of stuff incrementally because we had annual deadlines. We couldn't throw it all out and start over. We needed to kind of introduce efficiencies and as we went. Yeah. Yeah.
Great talk, Julia. It's really, really inspiring to see a tight-knit collaborative team working with these open science tools. It's awesome. I did have a question about the data. And what is the level of geospatial granularity of your work, and how much did you have to go into a geospatial database, which I think that, that's still a challenge as far as I'm aware with a lot of these open science tools, and just your impressions about the need for that geospatial intelligence and how you resolved it in OHI.
Yeah, so Casey can also help me on this since he does a lot of this work. But we, it's probably less than half of the data we use in global assessments that are geospatial. It would be great if they all were, but just that's not the way the data are that are available. So they come at different resolutions, and we process each data set separately in order to have a value per region before we start modeling. So there's quite a bit of pre-processing involved. We're doing as much of that in R now as we can. But in terms of the databases, we're not going to a single place for the geospatial data either. Some come from NOAA satellites, some are coming from UN repositories. So yeah, it depends, I guess, is the answer. Do you have anything to add, Casey?
I guess it would be important to think about the fact that for the global assessment, at least, we're looking at the assessment region as the entire EEZ. And so in a lot of cases, we don't need like fine-grained spatial data as long as we can aggregate it to the EEZ level. For some of the, like the OHI plus ones, where you're looking at a single EEZ and you break it up into smaller regions or districts or whatever, a lot of that is some of that is probably based on like the data that's available, and a lot of it is based on kind of the scope of like management that you want to be able to inform with it. And so it's a little tougher probably at the like the OHI plus level, but.
Thank you so much for the talk again.
Yeah.
So I have a question. How do you see this open source structure help inform our country's ocean management? Because we're so fractured in that regard.
That's a good question. So President Obama's ocean plan identified 8 regions for ocean management, and the Northeast, Northeast region has just accepted OHI as part of their scoring mechanism for their own management. So it is quite fractured, but I think if there's a group that takes the lead and develops a system, then others could follow and collaborate with as well, together as well. I don't know. So I don't know if you have anything to add to that too. I'm not. Yeah. I think the idea is that we're going to be developing models that are specific to the Northeast region using data that they have and their management targets, and then other groups might see that that's the way that they might want to go as well. Yeah. I think I just hit I think my brain just has shut off too, sorry. But yeah, I'm happy to follow up with you more about that too if you want. Yeah. Okay, thanks guys.
Well, thank you all.